Well, howdy chemists. We've survived week 5. We are officially over halfway through the quarter, and it's going to feel great to be moving forward and approaching the end of our time together, though that makes me sad now that I say that. So let's talk about our week 5. So highlights from our week. Sorry, there we go. So a big highlight from this week was our Unit 2 test. Or maybe that was the low light of your week. I don't know. But it did mean that we had a big event, a big assessment event, or maybe you haven't taken that yet. We also then would have had kind of 2 discussions because we had our unit test prep discussion, just like we did for Unit 1. And then we also then had our Module 5 week discussion as well. But really, the highlight of the week, in my opinion, is that now all of these mole jokes are get to be used and make sense and are fun, because the coolest people I know appreciate a good mole joke. My favorite thing to do on mole day every year is to actually write Avogadro's number on my hand and go around to faculty and staff and say, I have a weird mole. Do you think I should get it looked at? And then when I show them, they roll their eyes and stop talking to me. I don't know. I don't understand it. Weird. So we had a major learning outcomes. I apologize about having to throw more on there kind of right toward the end of the week. It's not that they were being added as much as they were left off. Hopefully it didn't cause too much problems because you could tell they were learning outcomes from the assignments, the questions in the learning, in our Edpuzzle videos, and then if you're working on the worksheets at all, you saw those kinds of questions. But I realized I had used an old sheet in writing that originally, and I apologize for that. Hopefully that didn't cause too much trouble in terms of preparing. Oh, that should say week 5. Sorry about that. So our discussion, we had 3 discussion questions this week. I want to talk about each. This is one of my favorite discussion questions to have with students because, one, it's kind of an interesting experiment, kind of weird, this idea of this scientist measuring this potted plant. If you were wondering how he did it, it was in a pot for 5 years. Interestingly, he also weighed everything he put into his body, so all the food that he ate, and also everything that exited his body. So yeah, interesting guy to hang out with at parties. So let's talk about his results and his conclusion. His conclusion was short-term kind of accepted, and then somebody came along and was like, oh, there's a problem. If I burn wood and you get like that ash or that, charcoaly type stuff, we know that that's carbon. And water does not contain carbon. And so you can't take H2O in, the vast majority of a plant's mass coming in being H2O, but turn that into carbon. As we saw this week, matter can't be created or destroyed. And so what you get out needs to be what you put in. Now, maybe not in the same chemical form, but in terms of its mass and the kinds of elements, it does have to be the same. And so you cannot get a carbon-based life form, which we all are, without putting carbon in. And so what it turns out is that plants get the majority of their mass as they're growing from carbon dioxide gas, not from water, not from soil, but from carbon dioxide gas. And that's not photosynthesis isn't something that we can do, so it's maybe a little bit hard to relate to. This experiment actually kind of led to an interesting, we're kind of ignoring gases in our scientific endeavor. And you guys get to hear my dogs adding their 2 cents. They agree. It had to come from carbon dioxide. So second question had to do with that barium hydroxide demo, which is a really, really cool demo. And you mix the 2 solids and suddenly the beaker has frozen to the block that you set it on. This is a great example of one of those endothermic reactions. So a reaction or a process, we're going to talk next week also about how phase changes can be endo or exothermic, or at least explore that a little bit more. But a reaction can be endo or exothermic too. And endo means into. It even kind of sounds like that. Endo, into. And so an endothermic reaction is one in which energy goes in to the reaction or is absorbed by the reaction, by the chemical species from the surroundings. Because of that, they the outside, the surrounding areas, the temperature drops because that thermal energy is then going in. So in that experiment, when the reaction is happening and it's absorbing energy from its surroundings, it's absorbing energy from the water that beaker is touching and from the air around it. And that drop in energy and that drop in temperature causes the water to freeze to the block of wood. A great example of an endothermic, and hopefully you got to read about or see some examples of exothermic reactions too, which can be really fun. One of my favorites, which we do in Chemistry 121, is when we use nitric acid to dissolve solid copper. And I use the word dissolve loosely because it's actually a chemical change, but we say dissolve, but it's not dissolving it, it's chemically eating it in a way. And the beaker gets really hot, and it gets so hot that it actually boils itself, like it begins to boil as you're working. So exo and endothermic. And then this last question about a mole of Skittles. Now, I was not necessarily thinking people were gonna get an exact answer, though some of you might have looked up some because this math can be found online. I did. I looked up some, like, oh, how big would it be? Because we know that mole is like the word dozen. The word dozen means 12. Well, the word mole means this really, really, really big number. And the reason we want to be able to use one word like mole for a really big number is because, as we learned before, atoms are so small. Like so incredibly small that a very tiny sample can have trillions and trillions and trillions of atoms. And I don't want to be working in scientific notation all the time. I want to be able to say things like 5 moles, when really that means, 5 times 602 sextillion. So if you had Avogadro's number worth of Skittles, or 6.023 times 10 to the 23rd, or 602 sextillion Skittles, how big would that be? Well, here are some interesting stats to give you some perspective. So let's say you were going to fill the Grand Canyon with Skittles. How many times could you fill the Grand Canyon with 1 mole of Skittles? Well, you would need 100,000 Grand Canyons in order to fill, to take a whole mole of Skittles and put them in. Or what if you wanted to line them up end to end and go around the earth? Well, you could do that, but it would go around the earth 191 trillion times. So I like those kinds of thought experiments or math, math you can mathematically figure out, or even just thinking about it, because it gives us an idea of, like, this is a really, really, really big number. Because if you have something just this big, Skittles not huge, and you have that many of them, and it's huge, 100,000 Grand Canyons, but the atoms that we're talking about are so incredibly tiny that's actually how many, 602 sextillion, that you have in about 3 teaspoons of water. That's how many molecules, at least. So I look forward to reading a little bit more on what you guys came up with. Not really looking for like an exact number on that, as it says there, but just to get an idea of, like, it'd be a lot. You couldn't put it in your pocket. I don't think a human being could eat a mole of Skittles. I'd be willing to try, but only the red ones, because all the other ones are gross. So what's coming up? Gosh, I did great today. This says week 5, but that's actually not true. You can see I did some copying and pasting that didn't work well. We're actually going into week 6. We're going into week 6, and the biggest thing that we're going to see there is then we're starting our Unit 3 content. So we'll be moving into our Unit 3 content. Hopefully this will make more sense by the end of the week. What kind of content is that going to look like? We're going to be talking about phase changes, so going from solid, liquid to gas phase. We're going to be talking about polarity, which relates to the comic, and then why water is liquid awesome. So I really enjoy this upcoming unit that we're going to be looking at. So what's next for you? Wrap up anything you have left. Finish up your discussion, your lab, your selfie. In regards to this week's lab, I did put out an announcement. If you do not have rubbing alcohol, there are some alternatives. We're just looking at the density of a liquid other than water. So we do want to have a liquid that has a known density. So I listed some possibilities and their known densities on the Canvas announcements. So take a look there if you don't happen to have rubbing alcohol, because rubbing alcohol is a little hard to find right now thanks to the coronavirus. So if you haven't yet, you want to make sure you take the unit test. It does close Sunday at midnight. Check feedback on any of your graded work. So your Module 4 quiz, your HOL labs as they're getting graded. So pretty much as soon as you get a grade in Canvas, you know that I've graded it, and you can go in there and check those comments. The answers for the next test won't publish for a bit after the, I don't know, sometime on Monday. So check that work when you're done. Let me know if there's any mistakes or concerns that you have. Make your initial post to next week's discussion once it's posted, if it hasn't posted yet. And then I'm going to do an extra credit opportunity next week as well. I am going to give extra credit in each section to whoever posts the best lab selfie. Now I know that could be kind of vague. What does best mean? And I can't tell you because I don't know. I'll just know it when I see it. Whichever one makes my heart happiest, I guess. I don't know. So I do think, make a comment then when you submit your lab selfie if you want to be in the running for extra credit. Write me a little submission comment on your lab selfie assignment on why you think yours is the best and deserves the extra credit. So you guys have a great weekend. Let me know if you have any questions or concerns, having trouble with the labs, etc. And I'll do my best to help you remotely. See you guys.